Okay, so let's start with question number 1 for exercise 2. Which one is a scientific hypothesis, a statistical hypothesis, and a prediction? So please note that the difference across the three is that the scientific hypothesis provides a description of the possible reason for the phenomenon, while at the same time highlighting the characteristic that could be an explanation for this phenomenon. A statistical hypothesis, on the other hand, focuses on the potential results after a statistical test and almost always involves the presence of looking at the presence or absence of significant differences, whereas a prediction tells us the expected results of the experiment. So if we look at the three statements on the screen, the first statement is that the 1 ml pipette will be most accurate because the meniscus is more easily identified. The explanation is provided. However, instead of giving us the feature or characteristic of the glassware that allows the meniscus to be more easily identified, it instead gave us the expected results. And that's why letter A, statement A, is a prediction. For the second statement, there is no significant difference in the accuracy and precision of the glasswares used to measure 30 ml. So as you can see, it focuses on the presence or absence of significant differences in the metrics that we are measuring. And because of that, statement B is an example of a statistical hypothesis. And then finally, for letter C, the glassware with the smallest diameter will be most accurate because the meniscus is more easily identified. So this statement provides us the physical characteristic of the glassware that allows us to check if the meniscus will be more easily identified. So it provides an explanation to the phenomenon that we are trying to investigate. And so statement C is a scientific hypothesis. Before we move forward to the next question, do you have any questions or points of clarification for item number 1? Okay, could you give me a thumbs up if we're clear with question number 1? Okay, so far 11 out of 19, 13 out of 19 participants gave a thumbs up. Hala, ano kayang ginagawa ng iba? Hopefully you're not asleep. We've just started. So anyway, moving forward, question number 2. Which type of hypothesis is needed for in ecology for most of the time, and why is this the case? So just like in question number 1, you have 3 options: a statistical hypothesis, a prediction, and the scientific hypothesis. If you were paying attention to our pre-lab for exercise 2, we emphasized that the scientific hypothesis is very much needed because the primary goal of ecology is for you to develop the skills needed to look for the most possible explanation to the phenomena that we are observing. Kasi nga, we are trying to debunk any and all possible explanations until we are left with the one that is most likely. Okay, so for question number 2, the answer is scientific hypothesis. If you have any questions or points of clarification, now would be the best time to ask. Otherwise, sige, para maiba lang, maybe give me a heart reaction if you don't have any questions about item number 2. Okay, so let's move on to question number 3. Given the following hypothesis pair, the larger the maximum volume, the more precise because of the less instances the water container needs to be refilled, And hypothesis number 2, the smaller the maximum volume, the more precise. So you'll notice that the hypotheses are designed in such that hypothesis 1 focuses on the larger the maximum volume, and it's the one with an explanation, and the second one provides its opposite. And then we have the following data, which shows the height of the bars represent the average volume of water measured using the 50 ml beaker, the 100 ml beaker, and the 200 ml beaker. And then you have your error bars representing the variation. So the first question is, which setup has significant differences with each other? So as described before, if you are not given the opportunity to do a statistical test, what you can do for question A is to look at the overlaps of your error bars. If the error bars are overlapping with each other, meaning if you draw a horizontal line across all three bars and pumapasok siya dito sa error bar ng isa't isa, then it means that, again, if the error bars are overlapping, then it means that there is no significant difference. However, wait lang, let me just clear this. However, if the error bars are not overlapping, then it means there is a significant difference. So tingnan lang natin yung extension ng error bar ng 50 ml beaker. As you can see, hindi siya tumatama sa error bar ng 100 ml beaker at 200 ml beaker. Dahil hindi niya natatamaan yon, the 50 ml beaker has a significant difference with the 100 ml beaker, and the 50 ml beaker has a significant difference with the 200 ml beaker. But kung titingnan naman natin yung error bars ng 100 ml beaker, pag in-extend natin siya to the left, as you can see, hindi siya tumatama sa error bar ng 50 ml beaker. Pero pag in-extend natin siya to the right, yung upper portion ng error bar niya ay tumatama sa lower portion ng error bar ng 200 ml beaker. So what this implies is that the 100 ml beaker has a significant difference with the 50 ml beaker, but the 100 ml beaker does not have a significant difference with the 200 ml beaker. And if we repeat the same kind of drawing with the 200 ml beaker and extend its lower bar to the left and its upper bar to the left, you can see that the error bar of the 200 ml beaker does not overlap with the error bar of the 50 ml beaker, but it overlaps with the error bar of the 100 ml beaker. So this means that the 200 ml beaker, again, has a significant difference with the 50 ml beaker, but the 200 ml beaker does not have a significant difference with the 100 ml beaker. So, because of this, and again, you always check for significant differences first before you proceed with hypothesis debunking. The next question is, which hypothesis or hypotheses are debunked? So the first hypothesis is that the larger the maximum volume, the more precise. But if you notice, the 200 ml has the largest maximum volume, but you can see that its error bar is the biggest. And because of that, hypothesis 1 is debunked. Hypothesis 2, the smaller the maximum volume, the more precise. We can see that the 50 ml has the shortest error bar. The 100 ml beaker has a shorter error bar than the 200 ml beaker. And since the 50 ml beaker has the smallest maximum volume, then hypothesis 2 is not debunked. So for question 3B, only hypothesis 1 is debunked. And finally, for question 3C, what could be the probable cause for the differences in precision? The only factor that we have here is the maximum volume, which is related to the size of the beaker. So the difference in the cause for the difference in precision could be the size of the beaker or its maximum volume. If you put other explanations here, that is called hand waving, because those are not the explanations that we're trying to test. So that's going to become very important in your discussion, because in your discussion, you have to focus on looking for the probable cause of the differences in precision. And the only thing you can tell us is if the physical characteristic that you looked at is the explanation. So is it the explanation? Yes. If yes, why? If the answer is no, then you move on to why it's not, and then you can give possible recommendations for other characteristics to test. Okay? So that's how you proceed with a discussion that does not do hand waving. Okay? So before we proceed to question number 4, any questions or points of clarification for item number 3 in any of the letters? Okay, if you don't have any questions, maybe you can give me the open mouth reaction, yung, okay, thank you for that. Hopefully, by practicing like this, hypothesis debunking would become more straightforward and clearer for everyone. Okay, so let me just clear the annotations. And let's move forward to question number 4. In executing the experiment, which method of randomization should not be used? A, randomized block design, B, completely randomized design, or C, systematic design. Explain your answer briefly. So both randomized block design and completely randomized design are good for exercise 2 because they allow for true independence of replicates. So either will give you good results, except that the statistical test that you use for a randomized block design is different from the statistical test that you'll use for a completely randomized design. Okay? So what you shouldn't use would be systematic design. Because in a systematic design, you remove the independence of your replicates. Because since you already defined the order of your experiments, you can now 100% predict or guarantee what glassware will be used next. And this can lead to bias, to expectations that could affect the accuracy or the measurement of accuracy of your experiment. Okay? So for question number 4, if you have things to clarify or ask about this item, now would be the best time to ask. Otherwise, if you don't have any questions for item 4, maybe give me a thumbs up reaction. Okie dokie. Next, let's go for question number 5. Oh, wait a minute. Somebody's calling me from DOST. 5 seconds, sabihan ko lang sila na nasa class ako. Okay, sorry about that. Project renewal season. Okay. Which is, I guess, timely because someone is asking about item number 4. So to repeat for item number 4, of the 3 randomization methods that we discussed in the pre-lab, randomized block design and completely randomized design are both perfectly okay for this exercise. Pareho silang okay. No single one is better than the other kasi they allow for true independence of replicates. It's just that if you choose a randomized block design, you have to use a different statistical test when you use one or the other. What you shouldn't use is a systematic design because this removes the true independence of your replicates. Dahil sure ka na kung anong glassware yung gagamitin na susunod, this can lead to bias. It can affect your expectations and how accurate you measure the liquid from the other. So Mariah, was that okay? Did I answer your question? Okay, good. So let's now move forward to question number 5. What is the minimum number of replicates required for this exercise? Should you aim for something higher? Why or why not? So when we say minimum, just like, if you want to pass this course, the minimum grade to pass is 60%. The minimum number of replicates for the exercise is 3 because three replicates is the minimum for you to be able to do any kind of statistical test. If you have less than 3 replicates, you will not be able to do any form of statistics. But the question here is, should you aim for something higher? Why or why not? The answer is yes, because the higher the number of replicates, the greater the power of your experiment. When we say power, it means the ability of your experiment to create concrete and real conclusions. So, yun. But when it comes to experiments like exercise number 2, wherein the more replicates you create, the greater the fatigue that is experienced by your experimenters, then the higher the number of replicates does not always mean the better. So what you're seeing here is a graph that shows the coefficient of variation in the y-axis and the number of replicates in the x-axis. And the higher the coefficient of variation, the less precise your experiment is. Kasi ibig sabihin, mas varied yung results nyo. And as you can see, if you have 3 replicates, your coefficient of variation is relatively high, not too high, but it's still higher than the usual. But if you do a level of replication that is between 4, 5, and 6, you can see that your variation is lower than when you just do 3 replicates. So this means if you do a number of replicates that's between 4, 5, 6, 7, maybe 8, then you will still get good precision. Pero so far, the highest precision that you can get, the lowest coefficient of variation, is at 5 replicates. So anywhere between 4 to 6 replicates would be good. But as you go higher, as you increase the number of replicates further, let's say you go to 7, 8, 9, and even 10, then your variation starts to increase again. And this is because the fatigue of the students can actually cause them to increase the error in the experimentation. So, even though the higher the replicates, the better, there are certain experiments wherein a higher number of replicates would be bad. So for experiment 2, for example, if you have 4, 5, 6 replicates, you're good to go. But if you try to do more than that, there's a chance that your data would actually suffer. Okay? So any questions or points of clarification for item number 5? If none, maybe you can give me a heart reaction. Okay, good. Next, let's move forward to question number 6. I think this is the last question for your exercise 2 quiz. Why should you be concerned about the temperature of water coming out of the tap or the faucet? And how do you plan to address this? So the water that comes out of the tap would probably have a different temperature than the temperature that we have in the room. Since our class is during lunch period, the environment outside of the classroom is very warm, and that's where the pipes of the water are coming from. But their classroom is climate controlled. I believe during the time of our experiment, we had a temperature of 24 degrees Celsius. So if you look at the temperature at 24, the density of water is just slightly less than 1. But if, let's say, the temperature of water was 38, dahil mainit yung tubig, as you can see, it's a lot less than 1 compared to when it's 24. So, we have to make sure that the temperature of water is consistent when we're performing the experiment. And that's why it needed to be acclimated or balanced out with the temperature of the room. So in order for us to do that, I placed water already in the large beakers that you had. And while you were taking the quiz, I let it sit on my table away from the windows that could be affected by the warmth of the sunlight so that it would balance out with the temperature of the room. Now, some of you tried to answer na aalamin nyo yung temperature no water by using a thermometer. Well, that gives you information regarding the temperature of the water and therefore its density. However, it doesn't stabilize the temperature. It is still better for us to have the water at a stable temperature because at the end of the day, the temperature of the water also affects the reaction of the glasswares. Pag masyadong mainit yung tubig, kahit alam mo yung temperature niya, pag nilagay mo siya sa glassware, pwedeng mag-expand yung glassware. Tapos, pag lumamig na overtime yung tubig, so kahit alam mo yung temperature niya, pwede naman siyang mag-cause ng contraction ng glassware. So as much as possible for experiments like exercise 2, you don't need to just know the temperature. You need to keep the temperature as stable as possible. But of course, for our exercise, we didn't really need to use a water bath or any other kind of technology because our classroom is climate controlled. And hindi naman ganun kabilis mag-fluctuate yung temperature ng water as long as it has stabilized to the temperature of the room. Okay? So that's for question number 6. Any questions or points of clarification about question number 6? Okay, give me an open mouth reaction if you don't have any questions. Okay, so most of you probably already know your scores for the quiz for exercise 2, but I will show you your quiz paper before we end the meeting on Thursday. It's just that you cannot take your quiz papers home. You cannot take photos of it. So what's going to happen is I'm going to be calling you 5 students at a time. You go to the front of the classroom. I show you your quiz. Once you've counted or asked the questions, you can go ahead and leave the room. So ganun po tayo, no? Hindi po namin sinusole or pinapauwi sa inyo yung quiz papers. But I will show it to you on Thursday. Okay? So now we'll move forward to our main activity for today, which is exercise 2 consultation. So at this point, these are the things that I need each group to show me. We'll start, this is how we'll do the consultation. Each group will be asked to present one item first. So for example, let me just make sure that everybody's allowed to share. We'll do descriptive statistics first. So I'll look at the descriptive statistics of group 1 first, followed by group 2, then group 3, then group 4. Once everyone has shown me their descriptive statistics, I'll give my comments and feedback. And then next, I'll hear what your proposed statistical test that you want to do, followed by, so one per group ulit. So group 1, group 2, group 3, group 4. Once everybody has told me what their proposed statistical test will be, I'll give my comments, and then punta tayo sa metrics of accuracy, punta tayo sa metrics of precision, and then graph. And then after that, I'll give you some time, or I'll walk you through the process of debunking the hypothesis. I'll close the Zoom room to give you time to eat and discuss with your group mates. And then babalik tayo sa Zoom room ng 1 p.m. for each group to show me the debunking of their hypothesis. And then I'll give you my comments again. And then my final reminders for your presentation on Thursday. Okay? So, sige, let's start with descriptive statistics first. I'll stop sharing. Group 1, please go ahead and share with me your descriptive statistics.
Yes, Miss.
Thank you. And thank you very much for that vocal confirmation for everybody. If it's an online presentation or consultation session, when I call the attention of your group, and let's say you're still preparing for screen sharing and whatnot, I would appreciate it if at least one member of the group vocally confirm, like, yes, miss, we'll just share. So I know that you heard my instructions, okay? So group 1, okay, go ahead, please scroll to the portion of your Excel sheet where the descriptive statistics are.
Here po, Miss. For these parts, we did these manual. And
Okay.
then, but the ones below, we also did the data analysis, the automatic for all 4 classifiers po.
Okay, so I see the 1 ml, 10 ml. Can you scroll down for the others? ml pipette, 10 ml grad seal, 50 ml beaker. Okay, thank you so much for that. I'll give my comments later on. You can now stop sharing group 1. Okay, group 2, can you show us your descriptive statistics, please?
Wait a sec po.
Okay, thank you for the confirmation. Okay, can you scroll
Here
down
po.
a little bit?
Okay.
Okay, so me. Okay, thank you so much for that. You can now stop sharing for the meantime. Okay, group 3, can you show me your descriptive statistics, please?
Okay po, miss. Screen share lang po.
Okay, thank you. Okay. Okay, thank you so much for that. Group 3, you can now stop screen sharing. Group 4, go ahead, please share.
Hello, miss. I'll screen share po.
Okay, thank you, Yona. Okay. Date, volume. Okay. Nakalagay lang yung 1 ml pipette pero hindi nyo kasi siya ginamit. So 5, 10 grad seal and beaker. Median mode. Okay, thank you so much for that. You can now stop screen sharing for the meantime. So, okay, so I've seen your descriptive statistics. I think it's okay for everyone. But one thing you might notice is for some groups, the mode indicates not applicable. So I won't, since majority of the class have already taken statistics, for the Q&A portion this coming Thursday, there might be some questions about your descriptive statistics. So the mean, the median, the mode, the kurtosis, and so on. So I hope everybody can brush up on what those statistical values imply about your data. But especially for the groups wherein the mode indicates not applicable, what does that mean? No? So para saan ba yung mode, ano yung information na binibigay niya sa atin, at bakit siya magsasabi ng not applicable. Now, for the groups na may NA, yung mode, don't panic. Hindi ibig sabihin nun mali or pangit yung data nyo. It's just that pag nag-NA yung mode, meron siyang ibig sabihin. And dapat alam nyo yung ibig sabihin nun. Okay? So that's the one for descriptive statistics. The next thing that I want to ask everyone is, what kind of statistics do you think you need to do? Okay, so I guess this time maybe let's hear from group 2 first. So no need to screen share yet. What statistical test do you think you need to do? Group
Hi,
2.
Doc. Am I audible po?
Yes, I can hear you.
Our proposed po na statistical test to be performed is one-way ANOVA po.
Bakit
Since-
one-way ANOVA?
Since we were debating po kasi whether to use t-test or one-way ANOVA, and the group agreed on ANOVA kasi if we use t-test can only test 2 samples at a time, and we think na this will introduce bias since we will choose which glasswares or what samples to compare. And I think with ANOVA po, all of the samples can be compared in one go po.
Okay, thank you for that, group 2. Let's see if group 3 has a similar preference. Group 3, how about you? What kind of statistics are you proposing to do?
Hi, Miss. For our group po, we're thinking to do a t-test po since it also has a sample size sample size lower than 30. So we came up with the t-test for the ano po.
Okay, so group 3 this time wants to compare using a t-test. Okay, thank you for that, group 3. How about group 4?
Miss. Hello po.
Hi.
For us po, one-way ANOVA din po. Because we all know nga po na yung ANOVA ginagamit po to if we have multiple glasswares, and we have 4 glasswares po. That's why we decided na this is the statistical test that we will use. Also for us to be able to determine din po if mayroon bang statistical significant difference sa means ng measurements across the different types po by analyzing the variability within and between groups po.
Okay, thank you for that. And then finally, group 1.
Yes po din, Miss. We're also planning to do ANOVA, pero we're also gonna plan to do post-hoc na testing po, either B-rays or two-keys test.
Okay, sige. Thank you for that. Okay, so I'm so sorry, but everybody's wrong. Okay. So just to confirm if I remember it correctly, everybody did a randomized block design, right? Meron bang completely randomized? Lahat kayo randomized block? Give me a thumbs up if that's true for your group. Did you do a randomized block design? Okay. Kung merong completely randomized, give me a heart. Pero kung randomized block kayo, give me a thumbs up. Okay, so everybody gives a thumbs up. Okay. So ito yung sinasabi ko kanina na pag completely randomized kayo versus randomized block, iba yung statistical test na gagawin. But again, when you're trying to figure out the statistical test, you have to figure out how many treatments you're comparing. The treatments basically refer to the groups that you're trying to check if magkapareho o magkaiba ba sila. So in this case, all groups investigated 4 glasswares. So each group had 4 treatments. Gagamitin lang natin ang t-test if we're just comparing between 2 treatments. But since you're comparing across 4 treatments, you have to do some form of ANOVA. However, a lot of you were saying you're going to do one-way ANOVA. But a one-way ANOVA is only applicable if you did completely randomized sampling. Kasi pag completely randomized sampling, isang bagay lang yung gusto nyong i-check. Kung may pagkakaiba ba across the 4 groups. However, since in your case you created blocks, you have to do an alternative test, which is to test if your blocks have significant differences with each other or none. Ideally, each block should be comparable to each other, meaning each block should have no significant difference with each other. Kasi kung merong significant differences yung blocks nyo, ibig sabihin, one block could have been performed differently compared to the others. And you'd have to remove that from your analysis. So yun yung danger ng randomized block design. So for later, siguro by 1 p.m., apart from showing me your debunking, I will need you to demonstrate to me how you're going to do tawag dito? In Excel, if you have the data analysis tool pack, you should be able to do a 2-factor ANOVA without replication. Kasi each block was only done once naman. So you have to do, again, a 2-factor ANOVA without replication so that you can check if your treatments have differences with each other and if each block has differences with each other. Now, yung post hoc, which group 1 has mentioned, you can do that if you find significant differences. Yung Excel natin, however, medyo mahirap mag-post hoc sa kanya. So you might need to use another statistical analysis tool to do your post hoc. But when you're doing post hoc, you have to check for equal or unequal variances. So that's another statistical test. Now, if hindi pa kayo ganun kaalam mag-post hoc test, it's okay, hindi naman tayo statistical class. You can also use the overlaps of your error bars to highlight which treatments have significant differences with each other. So you can claim to do that. Hindi ko naman kayo i-rush today. Okay? So again, the statistics that you need to do would be a 2-factor ANOVA without replication because each group had to do a randomized block design. And the reason for this is because you have to check if each block has a significant difference with each other. And ideally, wala, in order for them to be replicates of each other. Okay? Sige. Next, I would like to hear the metric of accuracy that each group would prefer to use. Your options would be absolute error and relative error. And again, our situation is that we only have one true value. So this time, let's start with group 3. What is your chosen metric of accuracy? Group 3? By the way, if you have any questions regarding the advice I give, please don't hesitate to ask. You can type in the chat or unmute. But group 3, can you hear me?
Hello po, Miss. Yes po, we can hear you. Our group is still deciding po.
So you don't have anything to give me right now? Okay, that's fine. Well, I mean, it's ideally you should have, but okay, thank you for admitting that. Group 4.
Miss, so sorry po for interrupting. Upon our conversation po, it's either two-way po or factorial.
For your metric of accuracy?
Oh, no po pala. For your question po, yung one true value po, miss.
Yes? What metric of accuracy will you use? Okay, so for everyone in the next consultation rounds, I hope that when I assign you some things to discuss, ideally by the time we meet, you've already discussed it in order to avoid deductions in your consultation grade. So final call, group 3.
Miss, the accuracy absolute error po.
Okay, thank you for that. Group 4, how about you?
Hello, miss.
Mhm.
The absolute error po.
Okay, so your group also wants to use absolute error. Group 1?
Yes, din miss, absolute error.
Okay, absolute error din daw. Okay, and group 2?
Percent error po.
Percent error, okay, or relative error. Okay, thank you so much for that, everyone. So in this scenario, the metric of accuracy, so I would just like to emphasize that the metric of accuracy will only be relevant if you see significant differences in your statistics. If there are no significant differences in your statistics, then your metrics of accuracy are just for decoration. Kasi pag no significant differences, ibig sabihin nun, equal yung levels ng accuracy ng glasswares. So, magmamatter lang yung metric of accuracy if you actually see significant differences across the treatments. But anyway, if for example, nakita nyo na yung beaker ay less accurate or ang beaker ay may significant difference across the glasswares, you use the metric of accuracy to check if kaya ba siya may difference kasi less accurate siya or more accurate siya. So in this case, we have one true value, which is 30 ml. Now the absolute error is computed by getting the difference between your mean, your average value, and your true value. The percent error or the relative error is computed by getting the difference, so subtracting the mean from the true value and then dividing it by the true value and expressing it as a percent. So in this scenario, since iisa lang naman yung true value natin, both absolute error and percent error are acceptable. Okay? The absolute error is useful kasi makikita mo talaga like by 5 ml po yung difference nila or by 0.5 ml lang po yung differences nila. So maliit lang or malaki. So mabilis ma-imagine kung gaano kalaki yung differences nila with each other. Yung percent error naman, useful siya if you have multiple true values kasi in ratio and proportion yung nakikita nating difference from the truth. So for example, pag nakita natin na 1% lang yung difference from true value, okay, malapit lang naman pala siya. Pero pag nakita natin na, 30% yung difference niya, naku, hindi yan accurate kasi malayo. So yun yung importance ng metric of accuracy. But again, please note na ang metric of accuracy, magiging useful lang yan if may significant difference kayo na nakita sa statistics. Kasi kung walang significant difference, kahit magkakaiba yung metric of accuracy nyo, ibig sabihin, walang difference. Hindi sila ganun ka nagkakalayo sa isa't isa. So that means they're equally accurate. Okay? So now we'll move forward to metrics of precision. So dito, I ask you guys to check out coming to see kung ano yung magandang metric of precision for our scenario wherein hindi feasible na magkaroon ng 30 replicates. And also, na alam natin ang true value. So yung iba kasing metric of precision, maganda siya pag mataas ang number of replicates. Yung iba naman, important siya pag hindi natin alam ang true value. Kasi may mga experiments na ganun, na hindi talaga natin alam kung ano ba talaga yung totoong value na dapat nating ma-measure. So the coming paper should be able to tell you what to use. So this time, another thing. Sige, anyway, sige, let's hear from group 4 first. Group 4, what metric of precision is your group planning to use? Group 4, can you hear me? Group 4? Last call, group 4?
Hello, sorry, miss.
Mhm.
We were thinking about the confidence interval, the CV.
CV is different from confidence
I mean,
interval?
sorry.
Coefficient of variation ng CV.
Yeah, sorry, that's what I meant.
So what are you going to use?
The coefficient of variance.
Coefficient of variance, so CV. Okay. How about group 1?
Hi, miss. We're gonna use the confidence interval po.
So confidence interval.
Yes po.
Okay. Group 2? Group 2, hello.
Hello, we're going to use standard deviation, standard error, and coefficient of variation.
Hala, bakit tatlo? Isa lang. Pili lang kayo ng isa. You don't need all.
Sorry. Standard deviation po.
Standard deviation. Okay, thank you for that. Group 3, how about you?
Miss, standard error po for us.
Standard error naman for them. Okay, thank you so much. Okay, so if you were able to read Cummings, there are two types of measures of precision. You have descriptive, and there are also inferential measures of precision. For the descriptive measures of precision, ginagamit lang natin siya to visualize how close the values are together or how far apart they are. So usually, ang descriptive measures of variation ay panggawa lang ng graph, pang-display, pero wala na tayong further conclusions na magagamit sa kanya. So ang descriptive measures of precision ay standard deviation at coefficient of variation. Ang inferential na measures of precision would be those that have dual purpose. Pwede siya for visualization, pero pwede rin natin siyang gamitin para mag-infer ng presence or absence of significant differences. So ang options naman natin for inferential would be standard error and confidence intervals. Ang standard error, ang useful pag maliit lang ang number of replicates natin if it's less than 10. And okay lang yun kasi standard error is also used if we know the true value. Now, confidence intervals are better used if you have a higher replicate count, let's say 30 and above, but it also has a secondary usefulness pag hindi natin alam yung true value. So we usually use confidence intervals or confidence levels if we're working with mensurative experiments in the field. Kasi syempre si God lang yung may alam ng true value niyan. But if we're doing experimental studies in the lab where we know the true value and we have less than 30 replicates, we use standard error. So for this exercise, I think it would be better if your metric of precision is inferential. And since we only have 4 to 6 replicates, to use standard error. Okay, is that clear? Can you give me a thumbs up if that's clear? Okay, good. So right now, obviously, hindi nyo naman pwedeng baguhin agad yung error bars nyo. So I just want to see a quick look at your graph to see what you have so far. And then later on, I hope you can adjust it na yung error bar nyo ay based sa standard error. So group 1, if you can screen share, I'd appreciate it.
Yes po, Miss.
Thank you.
This one, Miss, is when it's the, we call this total volume measured. But this one, Miss, is for the difference from 30 millimeters to true value.
Okay, so you have two graphs, one representing the mean, right? That
Yes,
green
Miss.
one. Okay, and then the other that shows absolute difference.
Difference.
Okay. And then
Also,
right
Miss,
now, the error
na-change.
bars are based on?
Well, kanina, Miss, confidence interval, pero
Na-change
just
nyo
now,
na.
yes.
Okay, sige. Mabilis lang naman kasi, no, pag alam mo na yung pipindutin. Okay,
Yes.
thank you for that, group 1. Sige, let's see from group 2. Okay, so this graph is based on the mean.
Yes, miss.
And the error bars right now are?
Standard deviation po.
Standard deviation. Okay, so later papalitan na lang ng relative error, ay ng standard error, ha?
Okay, miss. Thank you.
Okay, thank you for that, group 2. And then group 3. Okay. Sige. So group 3, this is based on mean. Yes? No?
Yes po, miss.
Okay, and the error bars are represented by?
Yes po, miss.
Sorry, what metric is being represented here by the error bars?
Yung error bars po, miss, I use the wait lang.
Sige lang. I think you can click it para makita mo kung ano yung source niya. Right click.
Standard error po, miss.
Naayos niyo na siya to standard error. Okay, thank you for that. And ano yung horizontal line na yan na just above 30?
Yes po.
What is that?
Ay, miss, dapat 30 po yan. Yan po yung true value po.
Okay, it's the true value line. Okay, sige. Thank you for that, group 3. Okay, next, let's hear,
Yes.
let's see group,
That's
yes?
the true value po.
Okay, thank you.
Yes
Let's
po.
hear, okay, sige, let's hear from group 4.
Hello, Miss. Here's a
Mhm. Okay, so can you, so 6 kasi meron kayong 6 na replicates, tama ba? Tapos ano yung error bar niyo dito? Hello? What value is your error bar?
Ano, yung error bar po, yung standard error. That's what we're using for the error bars.
Okay, you're already using standard error. Okay, thank you. Sige. Okay, so now that I've seen everybody's graphs, I can now guide you towards what should and should not be done. So first off, we don't graph individual replicates. You only graph the mean. Kasi the individual replicates are meaningless. Nagkakaroon lang sila ng meaning pag na-transform sila into measures of precision. So dapat, per glassware, meron lang isang bar. And then, yung bar graph na yon, meron siyang error bar. Kasi yung error bar ang nagpapakita ng variation. So, dapat, hindi pinapakita each replicate, dapat yung average lang or yung mean, tapos may error bar na ideally ay inferential. What we graph is the mean, not the absolute difference or the relative difference. Kasi ang absolute difference is basically a derived value. It's a value that we compute to imply something about your situation, which is in this case, accuracy. Dapat, gamit lang yung mean, kaya na nating makita kung alin yung pinaka-accurate or, kung alin yung pinaka-accurate. And then gamit yung standard error, kaya na nating makita kung ano yung pinaka-precise. Now, if everybody remembers, group 3, can you flash your graph again? Group 3, yeah, thank you. So, what's interesting about group 3's graph, however, is meron silang tinatawag na true value line. So, if I'm going to, where is the annotation? Anyway, nawala yung annotation button ko. Ay, ayun, lumabas. Annotate. So, ito yung true value line. Ideally, nakatapat siya sa 30. So, I guess i-adjust pa to ng group 3 kasi right now, mas mataas siya sa 30, no? Pero ideally, nasa 30 dapat siya. So, yung line na yan, ang pwede nyo siyang idagdag dun sa graph nyo so that it represents the true value. So that it's easier for you to check which among the glasswares are closest to the true value after you've checked for significant differences. Okay? So magandang complement yung true value line. And I hope all groups can use or use the true value line later on. Okay? So yun. Now, just some additional things for you to remember regarding the information that you're going to present. First, decimal places. Dun sa mga graphs na nakikita ko kanina. Sige, group 3, you can stop sharing na. Merong iba, sobrang daming decimal places. Yung iba naman wala. Yung iba 2, yung iba 1. So when it comes to decimal places, you have to ask yourselves, what number of decimal places would be relevant to this study? For example, kung magme-measure ka ng water using 1 ml pipette, hanggang anong decimal place lang ba yung kaya mong i-account? Kaya bang i-measure ng 1 ml pipette yung 5.128632 ml? Diba hindi? Parang siguro hanggang 5.2 ml lang yung kaya niya. And you have to ask yourself about the graduated cylinder then. Kaya ba niyang i-measure yung 12.28325678 ml or hanggang 52 ml lang ba? So the number of decimal places that you should use should be relevant to the glasswares that we used in the study. Okay? Not too much, but also not too little. For the graph, when choosing the colors of the bar, you might want to give a different color per glassware so that it's easier to interpret. And then for the labels of your graph, make sure that their size is big enough for them to be able to be readable when you place them on a slide. So at least 14 or 16 points yung size if it's aerial, to make sure na nababasa niya. And make sure that you have an x-axis and a y-axis label. So yung y-axis label, lagay niyo yung unit for volume if you used ml. And then for x-axis, yun nga, kung anong glassware siya. And once again, I would like to emphasize the importance of the true value line. Now, before I let you go to have your quick lunch break and then group meeting for your debunking and statistical test, I just have some things to remind you of, or at least inform you. So some of you have already started talking about confidence levels versus confidence intervals in terms of measures of precision. So once again, I would like to emphasize that we use confidence intervals as a measure of precision if we have 30 replicates or more, and it's usually preferred if we don't know the true value. So some students confuse that with confidence level, which is a value that we set when we're creating the analysis. So the confidence level is basically a representative of the number of times that you expect that your value will get close to the same estimate if you repeat the experiment over and over again. So ibig sabihin, kunyari nag-set tayo ng 95% confidence level, ang ibig sabihin nun, acceptable sa'yo if 95% of the time, magkakalapit yung values na mamimeasure mo. Now, the confidence interval is the measure of precision. It shows kung gaano kalayo yung value dun sa average. So it represents the upper and lower bounds of your estimate. So, kung kunwari, ang nakuha mong confidence interval is 0.25632, this means that if your mean is 30, then the highest measurement that you were able to get would be around 30.26, and the lowest that you were able to get would be 29.84 or 74? Yun, 29.74. So plus or minus your mean, yung value ng confidence interval. So the actual measure of precision is confidence interval, not confidence level. Kasi yung confidence level, kayo yung nagsiset. So this could be relevant for you in the future. That's why I'm sharing this with you now. Now, for debunking, since pag-uusapan nyo to, kung after nyong kumain or right now, depende sa inyo. So the first thing that you have to do when you're doing your debunking is to check for significant differences. Pag accuracy, important yung significant differences. Kasi pag walang significant difference, ibig sabihin nun, the values for all 4 treatments are equal. So this means glassware 1 has an equal accuracy as glassware 2, has an equal accuracy as glassware 3, and has an equal accuracy as glassware 4. However, if significant differences are found you might need to do a post hoc test, or you try to look at the overlaps of the error bars to see kung aling glassware yung naiiba. Okay? Kasi if may significant differences, you look at the trends of the items with significant differences. Nafa-follow ba niya yung expectations na meron kayo? And again, yung expectations na yun is based on the ranking you created. So let's say your hypothesis states that the smaller the maximum volume, the more accurate. Then your ranking would be the 1 ml pipette would end up being the most accurate, followed by the 5 ml pipette, followed by the 10 ml grad seal, followed by the 50 ml beaker. Nasusunod ba nun yung ranking mo? If yes, nasusunod siya, then that hypothesis is not debunked. However, kung hindi niya nasusunod yung ranking, then that hypothesis is debunked or at least partially debunked. Okay? So I need you to try and do this later, and then I'll give you advice if you're going at it the right way or the wrong way. Now, a note on precision. So, mag-gauge nyo yung precision by looking at the size of your measure of precision, kung gaano kalaki ang inyong standard error. And in this case, the bigger the standard error, the less precise the glassware is. Whether you find significant differences or not, the metric for precision will still be useful. Important pa rin siya. Kasi, ang statistical tests natin, minimeasure lang niya kung magkakapareho or magkakaiba yung average. Pero may iba pang test para mag-check kung yung variation ay similar or not. So, if you want, you can do that test. Pero otherwise, kung you don't want to do that test, okay lang naman, pwede nyo pa rin i-compare ang significant differences whether you find, pwede nyo pa rin i-compare yung precision whether you find significant differences or not. Okay? So, yun. So, any questions or points of clarification for debunking? Huwag kayong ma-shy. Libre po magtanong. Okay, so sige. Kung wala, I will close the Zoom room now. I will see you all at 1 p.m. So at 1 p.m., I hope you can show me your statistics. So sinabi ko na ha kung anong statistics ang gagawin. 2-factor ANOVA without replication. And kaya nyo siyang gawin using Excel. Pag may nakita kayong significant differences, you can either do a post hoc or use the overlaps in the error bars to check which glassware has a significant difference with the other. Pero kung wala kayong nakitang significant differences, then that's it. Okay? After you do the statistical test, you do your debunking. Okay? We'll consult that all at 1 p.m. Okay? So I'll see you back here at 1. Thank you so much for your efforts. I really appreciate it. See you in a bit. Thank you, guys.